Hello, so in this video, we're going to find the derivative of the square root of x using the definition of the derivative. So the first step is to write out the definition of the derivative, which is f prime of x is equal to the limit, as h approaches 0, of f of x plus h minus f of x, and that's all over h. So here we can plug in our function f of x into our limit, and this becomes limit as h approaches 0 of the square root of x plus h. So I'm just plugging in x plus h as x here, minus the square root of x over h. And so this is where this problem becomes tricky, because there's no obvious next step. We can't take the limit right now because we would have a 0 in the denominator. We really need this h to cancel out, or other terms to be in the denominator. And, I want to remind you of a property. We have an x plus h minus x. So it'd be really useful if we could get these square roots out of the numerator. And I want to remind you of a property. If we have a plus b times a minus b, this is equal to a squared minus b squared. And so we can use this property here. We can set a equal to x plus h, the square root of x plus h, and b equal to the square root of x. And that will help simplify the expression by multiplying by a factor of 1 using this expression. So what I mean by that is we're going to multiply this whole thing by 1, but we're going to put 1 in a different form. So here, 1 is going to take so you see here that this is just one number over the same number. So this is just equal to 1. So we're not changing the answer, but this is going to greatly help us simplify this expression. So we can do some algebra out here. So we have x plus h minus square root of x times square root of x plus h plus the square root of x. And that's now all over h times that. Okay, and like I said, this top part will come to x plus h minus x. And if you do the algebra out, so if you multiply this times this, this times this, and that, you'll get this. Things will cancel out to get you to this. And that is all over h times square root of x plus h plus the square root of x. All right, now these x's cancel out, and we're left with the limit as h approaches 0 of h over h times the square root of x plus h plus the square root of x. And this is really helpful because these h's cancel. And so we're left now with the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. And now we can actually apply the limit because we don't just have a solitary h. The denominator won't be 0 in this case. So if we apply the limit, this h becomes 0, and we're left with the limit as h approaches 0 of 1 over square root of x plus the square root of x. And we already applied the limit, so we can get rid of that. And so now we're left with 1 over 2 square root of x. So I just added these two square roots. And that is our answer. That is the derivative of the square root of x. Thank you for watching.